Welcome back to Math Concepts. We are going to continue our work in the topic of probability. As we discussed in the previous video, we can assign a number to how likely an event is by making a fraction. And in the numerator of that fraction, in the top, we're going to have the number of ways our event can happen. And in the denominator, we're going to have the number of things that could possibly happen. So when we're dealing with probabilities like this, it's a matter of counting the things that meet our criteria versus the things that could possibly happen. So in this video, we are going to show how to use certain logical counting principles to make that job easier. Alright, so after watching this video, you should be able to apply the counting principles to determine how many elements are in a sample space. So let's look at this example right here. We're going to imagine that a state issues license plates that have 3 letters followed by 3 digits. So the question we're asking is, how many plates are possible? And what we do is we think in stages. Okay, we have 3 letters followed by 3 digits. So we have 6 stages altogether. Now, in this first part of the example, we're going to imagine the case where repeats are allowed. In other words, you could have AAB or AAA. You can repeat letters, you can repeat numbers. Okay, so you have 6 things to do. If I want to tell you my license plate, if I live in this state and I want to tell you my license plate, I got to tell you 6 pieces of information. The first 3 are going to be letters. So this is the first letter. And that's a space for the second. And then the third. This is the first digit. And this slot represents the second and then the third. Okay, so if we're going to just make a license plate at random, we have 26 choices for this first letter. We could choose any letter of the alphabet that we want. And since repeats are allowed, we also have 26 choices here and here. Now once we get to this stage, things change up a little bit because we're no longer using letters. We now have to give you a number 0 through 9. So you have 10 choices there, and since you can repeat, you have 10 choices here and 10 choices here. Okay, so what I'm going to do is I'm going to grab my calculator to crunch the numbers on this. So 26 times 26 times 26 times 10 times 10 times 10, and my calculator is giving me this number here. Okay, so that's 17,576,000 license plates. Now, what I want you to pay attention to here, of course, is the idea that we used to get this number. Okay, we looked at the task that we were talking about, dealing with a license plate, and we broke it up into stages. We had 3 letters followed by 3 numbers. So if I want to tell you my license plate, I got to tell you 6 things. That's why we have 6 stages. And then we look at the way each stage could possibly go. All right? So when you're talking about that first letter, well, it could be any letter of the alphabet. So you got 26 options. And since you're allowed to repeat, you got 26 options here as well. And so on down the line. So some notes on this. Break the task up into stages. Look at the number of ways each stage could be completed. And then the last thing you're going to do is multiply all those numbers. Okay, so break the task into stages, look at the number of ways each stage could be completed, and then multiply. Okay, let's do the problem again, except let's imagine the situation where repeats are not allowed in your license plates. Okay, so you're still going to have 3 letters followed by 3 digits, but here's the difference, okay? When I tell you the first letter in my license plate, that could be any one of the 26 letters of the alphabet. However, when I tell you the next letter in my license plate, I only have 25 choices. Think about it, right? I'm not allowed to repeat. So let's say the first letter in my license plate, let's just say, for example, it was L. The next letter cannot be an L. It has to come from the other 25 letters of the alphabet. And since we're not allowed to repeat either of these in the next stage, now we're down to only 24 choices. And down over here, we would have this. When I get to here, I'm talking about the digits in my license plate. For the first one, that could be anything. I have all 10 possibilities on the table. When I get to the next one, I can't repeat. So if this was a 7, that next digit has to be one of the other 9 numbers. It can't be a 7. It can be a 0, 1, 2, 3, 4, 5, 6, 8, or 9. I don't have 10 possibilities anymore. I've only got 9. Okay, and if we want to, we can crunch the numbers on our calculator. We'll do 26 times 25 times 24 times 10 times 9 times 8. And we are getting 11,232,000 possibilities. Okay, so you'll notice up here this is a bigger number than this, and that makes sense because here we made a restriction. Up here you're allowed any numbers and any letters in any spot that you want. Down here you're not allowed to repeat, so it makes sense that there's less. Okay, one thing I would like you to note here, this is sometimes called counting with replacement. Okay, if we imagine like pulling letters out of a hat, we have a hat with all 26 letters in it. So that first draw, you can get any of the 26. Now, since you can get any of the 26 on the second draw as well, it's like you've put that letter back in the hat, and it's eligible to come out again. Whereas here, this is like without replacement. We imagine all 26 letters in the hat. You pull the first one, that could be any of the 26. If we don't put that letter back in, if we don't replace it, then now you're down to 25 choices, and then 24, and so on. Okay, so that's an example of using the counting principles to figure out how big our sample space is.